We're going to talk about apertures and how apertures affect our exposure triangle here. So first let's find apertures on our cameras and lenses. So in modern digital cameras, you'll probably see them kind of on the left. You'll see either a panel or maybe the menu on the back of your camera, but you'll see usually kind of that F for f-stop and then the aperture, in this case 5.6. Or on the right, you might see them in other places as well. So there is the aperture ring on a lens, typically on an older lens, not as common. And then if you look through viewfinders, a lot of times you'll see them as well. So this gives you an idea of your apertures or f-stop range. You can kind of see that the smaller the number, so in this case f1.4, the bigger the hole. And the bigger the number, the smaller the hole, in this case f16 in this picture, or f22 on this row. So that kind of just shows you there. Now that the hole lets in a certain amount of light. Big holes more light, small holes less light. So kind of a similar thing. You can kind of see this here, but it's showing this idea that as you can look at 5.6, this is F5.6 is twice as much light as F8 or half as much light as F4. So you can see that one stop difference. And everything in hole stops is either double or half. So you either double the amount of light or you half the amount of light. So some things that we might want to consider here and how we get the terms or f-stop numbers. I don't make you memorize this by any means, but here is the actual equation that helps you figure this out. So your f-stop is determined by your lens focal length divided by your aperture diameter. So in the example on the left, a 100 millimeter lens divided by an aperture diameter of 25 millimeters equals f4, whereas a 200 millimeter lens divided by a 50 millimeter lens opening, that would give you f4 on that lens. So it kind of shows you, we're talking millimeters as the circle when you look kind of on the front of your lens in that case there. So the focal length on top, the circle that's the size of the actual diameter of the lens on the bottom. So then we've got our depth of field stuff. So the depth of field is the area that is basically being focused, and the fall off there is what is out of focus. So here's how apertures affect depth of field, and that's all I'm really going to pay attention to right now. And that is if you have that f2.8, you're going to have a large hole and shallow depth of field. In this case, you can see the architecture is blurry in the background behind the subject. Whereas if I look in the one on the right, you can see that at f22, the small hole gives me greater depth of field. In this case, I can see the person in the foreground and the background both in focus. So just to kind of remind yourself there, the smaller the aperture size, the more that a scene will be sharp. More depth of field. The larger the aperture size, the less the scene will be sharp. So you have less depth of field possible.